So, last time in class, last week, we mentioned about the sampling theorem and how we had to take a certain amount of samples in order to accurately represent an analog input signal as a digital waveform. Right? So for today, what we're going to talk about is how uh, we can how we actually physically convert an electrical signal from a analog signal to a digital signal. So all digital devices work on the idea of bits, or the idea that we have values that are either binary or true or false, right? So one, and those are represented by ones or zeros, right? So we can combine bits to create numerical words. A common numerical word is a byte, which is a collection of 8 bits, all right? And we have 2 to the m. The maximum unique values we can have of a numerical word is defined by the number of bits, and that maximum number of combinations is 2 to the m. Okay. So if we have 4 bits, the most that would correspond to 16 unique combinations of words. Okay. 16 unique combinations. Okay. Um, so there's binary codes. Those represent are used to correspond to different numbers. And then we have binary coded decimal signals. Each of these series of bits represents a decimal place. So, for example, if we had 532, we could represent that using four byte word, or sorry, three 4-byte words. So the first one would represent the hundredths data say point, which would be 5. So we represent it with the digital word for 5. And then for 3, we would represent it with the digital word for 3, which is 0011, and that would be multiplied by 10 to the 1. And then we'd multiply our last digit 2 by 10 to the 0, or 1. Right? So we can combine those to give us our decimal signal. Okay. Um, so here's some examples of different binary codes um, that are used to represent different digital numbers as well as letters. Right. Um, so um, so we'll do a quick example. All right. So we're going to try to convert this digital word to base 10 using the straight binary system. Okay. So what we do is we multiply each of the coefficients by 2 to that power. So the first decimal place represents 2 to the power of 3. Alright, so we multiply 0 by 2 to the power of 3. Then we would do the next place. We would have 1 times 2 to the power of 2 plus the next decimal, our next bit would be 0 times 2 to the 1, and our last data point would be 1 times 2 to the 0. Okay? So if you convert this all over, we end up getting we get 0 times 2 to the third, which is 0. 1 times 2 to the squared, which is 4. So we get 4. And then we get 0 again, and then we get 1 times 2 to the 0, or 1 plus 1. Right? So we end up getting 5 in this case. Okay. So very simple to understand, but we're not going to focus too much on this, but if you ever see something in a binary code, this is how you can convert it to a base 10 number.